For this next section, we're just going to check whether a pair of functions are inverses or not by finding the inverse of one of them, and then we'll write yes or no. So number one, we have f of x and g of x. We want to check if they're inverses. I'm going to use the top one. So f of x equals negative 10 plus x. And just like in the last video, I'm going to use y instead of f of x. Once you write it using y equals, you switch x and y. And then we're going to solve for our new y. So to get y by itself, you would add 10. So x plus 10 equals y, or y equals x plus 10. So this would be our inverse. So here we have 10 plus x, which is the same as x plus 10. They just swap the order. So this and this one match up. So that means these are in fact inverses of each other. So our answer is yes. For number two, let's do the same thing. I'm going to start with f of x, and I'm going to write it using y equals. Then I switch x and y. And now I'm going to solve for my new y. So in order to get y by itself, first I would add 15. So x plus 15 equals 5y. Next, to get y by itself, you would divide everything by 5. So y equals 1x plus 15 over 5. I'm going to split this into two fractions because I want to make it look like this answer here. So it could equal 1/5 x plus 15 over 5. And then if we simplify, 1/5 x stays the same, but 15 over 5 is 3. So we get 1/5 x plus 3 for the inverse. Here though, we have 1/5 x plus 15. So since they're not exactly the same, they don't match up. So that means these ones are not inverses of each other. So the answer would be no. For this last one, we're going to do the same thing. So I'm going to use g of x. So I'm going to write it using y equals. Then I switch x and y. And now I'm going to solve for my new y. Here they're multiplying negative 4. The opposite of multiplying negative 4 would be to divide negative 4. I'm going to put imaginary 1 here. So I'm going to write this so it looks like this. So we have 1 over negative 4, or negative 1/4, x equals y. Usually when you have one negative, you can just put it in the front. Now, these answers look very similar, but one's negative and one's positive, so they're not exactly the same. So that means these are not inverse functions of each other. So you have to get the exact same thing. Now, you don't have to do this in your assignment, but inverses are also special. So I'm going to look at the one where they were inverses again. And this kind of ties into what we learned in the last assignment. So if functions are going to be inverses of each other, basically when you do the composition, like f of g, g of f is going to be equal to it, and they're both going to equal x, which is that special line that they reflected across in the last video. Again, you don't have to do this, but I want to show you that it works to prove that they're inverses. So if I wanted to find f of g, I would plug g into the x that we have on f. So it would become negative 10 plus, but for x I would put 10 plus x. Here you'll notice the 10's cancel, and all that's left is x. So f of g is x. Now we did the same thing with g of f of x. This time we're going to use g, which is 10 plus x. But for x, I'm going to plug in f, because that's my input, negative 10 plus x. Here again, the 10's cancel, and you're left with x. So both the compositions of f of g and g of f are equal to positive x, which is that line of reflection, and that also proves that they're inverses. But for this lesson, when you're checking if they're inverses, you can just solve for one of the inverses and check if they match up.